Welcome to the deep dive. We know you've got sources and want the key info, like, right now.
Yeah, time's valuable.
Exactly. So today, we're diving into something super important if you're using large language models: prompt engineering.
Mm-hmm.
Think of this as your fast track to getting results that actually work.
Right. Getting beyond just basic questions.
Our mission today: unpack how to write smart prompts, those text inputs, and also how to tweak the LLM settings. The goal is accurate, insightful outputs.
And you've given us a great source for this prompt engineering dated February 2025. It's really thorough. It covers how to make LLMs truly understand what you need.
Yeah, it looks comprehensive.
And it stresses a key point.
Yeah.
And anyone can type a prompt, sure, but effective prompting. That takes knowing the techniques, understanding how to configure the model's response. That's the real power.
And it's not just for data scientists anymore.
Not at all. It's becoming a core skill for, well, almost everyone interacting with these models.
Okay, let's get into it. First up, something you just mentioned. It's not just the prompt, but also configuring the output. The source calls this LLM output configuration. Let's start with output length.
Right, controlling the number of tokens. Tokens are basically the chunks of text the model works with.
So more tokens means more detail.
It can, but there's a catch. More tokens need more compute power, more energy, more time, and yeah, more cost.
Right.
And a really important thing the source points out, reducing the output length doesn't automatically make the answer shorter or more succinct in meaning.
So it just cuts it off.
Exactly. It just stops generating at that limit. Could be mid-thought, even mid-word sometimes.
Okay. Need to be careful with that, especially for some techniques.
Yeah, like React, which we might touch on later. You don't want it rambling on after it's found the answer.
Got it. So output length is a hard limit. What about sampling controls? The source says LLMs predict probabilities for the next token, and sampling decides which one gets picked. This brings us to temperature. How do you think about temperature?
I think of temperature as, like, the creativity knob. Turn it low, near zero, and the model gets really focused.
Like laser focus.
Pretty much.
Yeah.
It picks the word with the highest probability. Very deterministic, good for facts. Though even at zero, if two words have the exact same top probability, you might get tiny variations. But generally, super predictable.
Okay, so low temp for facts, high temp.
High temp opens things up. The model's more willing to pick less likely words, more diverse, more unexpected, maybe more creative results.
Like brainstorming mode.
Exactly. Brainstorming. You might get brilliant ideas, but maybe also some less relevant stuff you need to sift through. The source links this to the softmax function internally, how it weights the probabilities.
Right, so low for facts, high for creativity. Makes sense. But there's also top K and top P. How do they fit in? They also seem to control word choice.
They do, yeah. They're filtering methods applied before sampling, usually. Top K is pretty straightforward.
It's just a number, right?
Yeah. It just says only consider the top K most likely words. High K, more options, more creativity. Low K, more restrictive, more focused. If K is 1, it's called greedy decoding. Just picks the absolute most likely word every time.
And top P?
Top P is a bit different. It looks at the probabilities of the top words and keeps adding them up until the total probability reaches a threshold, P.
So like a probability budget?
Kind of. All the words that fit within that probability budget are considered. A low P, close to 0, usually just picks the top one, similar to low K. P equals 1 means you consider almost everything.
So you can use K or P, or sometimes both.
Yeah, the advice is usually to experiment. See what works for your specific task. Sometimes you use one, sometimes the other. Sometimes platforms let you use both together.
Okay, so how do they all interact? Temperature, top K, top P.
They work as a team, really. And the best combo depends on the application. In something like Vertex Studio, if you have all three on, typically top K and top P filter the word list first.
Narrow down.
Exactly. Then temperature influences how the model samples from that smaller filtered list.
What if you only have K or P?
Then just that filter applies before sampling. And remember, extreme settings matter. If temperature is 0,
It always picks the top word, so K and P don't really do anything.
you got it. They become irrelevant at that point.
The source gives some starting points, like temp 0.2, top P 0.95, top K 30 for a balance, and temp 0 for things like math problems.
Yeah, those are good general guidelines to start experimenting with, but it also gives a warning.
Right. Too much freedom can lead to irrelevant text.
That's the trade-off. Creativity versus coherence. You need to find that balance.
And speaking of problems, the source mentions a repetition loop bug. Sounds annoying. The model just repeats itself.
Yeah, it can happen. And weirdly, it can happen at both low and high temperatures.
How come?
Well, at low temps, it might get locked into a high probability sequence that just happens to loop. Too deterministic. At high temps, the randomness might accidentally lead it back to a previous state, and then it gets stuck.
So fixing it means tweaking those settings carefully.
Exactly. Adjusting temperature and top KP to find that sweet spot between predictable and, well, stuck.
Okay, configuration makes sense. Let's move to the prompts themselves. The source starts with the basic general prompting, or zero shot.
Right, zero shot. This is the simplest way. You just give the LLM the task description and maybe some starting text, a question, instructions, start of a story.
But no examples of what you want back.
Correct. Zero examples. It relies totally on its training data and understanding of your prompt. The source mentions Vertex AI Studio is good for testing this out.
Table 1 has an example, classifying a movie review. Her is a disturbing study. I wish there were more movies like this masterpiece. Sentiment. And the model says positive.
Yeah, and notice the complexity, disturbing, and masterpiece in one review. The model has to figure that out with no prior examples for this specific task.
And the source notes documenting prompts is crucial. We see that table format.
Absolutely vital. Keep track of what you tried and what worked.
Okay, so building on zero shot, we get one shot and few shot. This is where examples come in.
Exactly. If zero shot isn't cutting it, you give the model examples. One shot is just a single example. Input, desired output. Like, here's one to copy.
And few shot is more than one.
Right. Multiple examples. Usually 3 to 5 is a good starting point, the source suggests, but it depends. More complex tasks might need more, or you might hit model input limits.
Table 2 shows parsing pizza orders into JSON. It gives a few examples, like a regular pizza, then a half and half one.
Yeah, showing that variety is key. The examples teach the pattern or structure.
But the examples need to be good, right? Relevant, high quality, maybe cover edge cases.
Crucial. The model learns directly from them. Bad examples, confusing examples, incomplete examples, they'll just confuse the model or lead to bad output.
Garbage in, garbage out, basically.
Pretty much. Even small mistakes matter. And including those edge cases, the weird orders, the unusual situations, makes the model much more robust.
Makes sense. Now, system, contextual, and role prompting. These sound like different ways to provide guidance.
They are. They add layers of information. System prompting is the big picture.
Like, you are a translator, or classify this text.
Exactly. Sets the overall purpose. Contextual prompting is about the specifics for the current task. Background info it needs right now.
And role prompting.
That's giving the LLM a persona, like act as a pirate or respond like a formal historian. It affects tone, style, knowledge base.
Do they overlap?
They can, yeah. A system prompt might imply a role, but thinking about their primary purpose helps design clearer prompts. System is capability. Context is task info. Role is style and voice.
Okay, let's break those down. System prompts. Table 3 shows 1 telling the model to only return an uppercase label for review sentiment.
Right. Very specific output format. System prompts are great for that. Or asking for code in Python, or like in Table 4, outputting structured data like JSON.
Ah, the JSON example. It even includes a schema in the prompt. What are the benefits there?
Big ones. No manual formatting needed later. Forces structure, potentially reduces hallucinations because the model has to fit the schema. Can even handle things like sorting data if the schema includes types like Bates.
And you mentioned safety earlier. System prompts can do that too.
Definitely. Instructions like be respectful in your answer are a common use of system prompts to guide behavior.
Okay, now role prompting, giving it a personality. Table 5 has the model acting as a travel guide for Amsterdam.
Yeah, and it suggests museums. Change the role to, say, a geography teacher, and you'd get a totally different answer, probably focusing on canals or land reclamation.
So the role provides tone, style, expertise.
Exactly. The source lists styles, too. Humorous, formal, persuasive, etc. Table 6 combines the travel guide role with a humorous style for Manhattan.
Right. Empire State Building, MoMA, Fifth Ave, but with jokes. It adds flavor.
A lot of flavor. Role and style together are powerful for tailoring the output.
And contextual prompting, providing background. Table 7 sets the context as writing for a blog about 80s arcade games, then asks for article topics.
Precisely. That context blog about retro 80s arcade games ensures the suggestions like cabinet design, iconic games, pixel art are relevant. Without it, the model might suggest anything. It focuses the model on the immediate task's specifics.
Okay, got those. Now for some more advanced stuff. Step back prompting. Sounds intriguing. You ask a general question first.
Yeah, it's clever. Before your main specific question, you ask a related but broader one.
Why?
It sort of activates the relevant knowledge in the LLM, primes the pump, you could say, gets it thinking along the right lines.
So it encourages deeper thinking.
It seems to. It encourages critical thinking, accessing general principles first, which can lead to better, maybe less biased answers on the specific task. The source contrasts a direct prompt for an FPS-level storyline with a step-back approach.
Yeah, Table 8 is the direct prompt, gets a generic urban ambush. Table 9 is the step back.
Yeah.
What are 5 fictional key settings? Gets things like abandoned bases, cyberpunk cities.
Exactly. Then Table 10 uses one of those settings, underwater research facility, as context for the storyline prompt, and the result is much more specific and engaging.
That's cool. Okay, chain of thought. Code ET. This is about getting the model to show its reasoning steps.
Right. You prompt it to think step by step or similar. It generates the intermediate reasoning before the final answer.
The math problem example is stark. Table 11, direct prompt, wrong answer, 63. Table 12, add, let's think step by step, correct answer, 26, with the reasoning laid out.
It's a powerful illustration. Cody helps the model break down problems, improves accuracy, especially for multi-step reasoning. Plus, you get interpretability to see how it got the answer.
And the source says it works well off the shelf, no fine-tuning needed.
Generally, yes, and it seems pretty robust across model versions. The downside, more tokens.
Right, longer output, more cost.
But often worth it for the accuracy gain. And Table 13 shows few-shot COTI, or you give an example of step-by-step reasoning too.
So COTI isn't just zero shot.
No, you can combine it with few-shot, useful for complex stuff, code generation, even creating synthetic data by guiding the assumptions. Anything you could talk through.
Okay, then self-consistency builds on COTI.
Yeah, COTI often uses that greedy approach, just picking the most likely next step. Self-consistency tries to improve on that.
Yeah.
You run the COTI prompt multiple times, but with a higher temperature.
To get different reasoning paths.
Exactly, generate diverse reasoning paths. Then you look at the final answer from each path and pick the one that shows up most often, majority vote.
Like wisdom of the crowd, but the crowd is the LLM thinking differently each time.
Good analogy. The email classification example in Table 14 shows this. Is the hacker's email important or not important? Different code runs might give different answers based on interpretation. Self-consistency takes the most frequent answer across many runs.
More reliable, but sounds expensive. Multiple runs.
It is more costly, yeah, but can significantly boost accuracy and coherence.
Then tree of thoughts, TOTI. The source shows a figure comparing it to COTI. COTI looks linear. TOTI looks like a branching tree.
Right. TOTI generalizes COTI. Instead of just one path, it explores multiple reasoning paths simultaneously. It maintains a tree of thoughts, intermediate steps, and branches out.
Better for really complex problems where you need to explore lots of options.
That's the idea. Problems requiring significant exploration or backtracking.
Okay, now react, reason, and act. This sounds like the LLM using tools.
It is. React combines the LLM's reasoning capabilities with the ability to perform actions using external tools like running a search query or executing code. It's a step towards agent-like behavior.
Mimicking how humans solve problems think, then do something to get more info.
Precisely. The LLM generates a thought about what it needs to do, then an action, like using a search tool, gets an observation, the result, updates its thought, and loops until it solves the problem.
The Metallica Kids example is great. Snippet 2 shows the output. Thought, action, search James Hetfield children, observation. Repeated for each member until it gets the answer.
Yeah, it clearly shows that loop. It requires sending back the history and giving good instructions, but it's very powerful for tasks needing external information or computation.
And automatic prompt engineering, APE, using an LLM to write prompts for you.
Kind of meta, right? The idea is to automate finding good prompts. Prompt an LLM to generate candidate prompts for your task.
Then evaluate them.
Exactly. Use metrics to score the outputs generated by those candidate prompts. Pick the best one, maybe tweak it, repeat.
The example is generating ways to order a t-shirt. One Metallica t-shirt size S. Get the LLM to write 10 different phrasings.
Right. Then see which phrasing works best when fed back into the chatbot you're trying to train.
Clever. Lastly, code prompting. Gemini helping with code writing, explaining, translating, debugging.
Yeah, super useful. Table 16 shows generating a bash script to rename files.
And it looks well commented too.
Usually, yeah. But the source rightly warns, always check generated code. LLMs repeat patterns from training data. They don't truly reason about the code's correctness or security. Test it thoroughly.
Good warning. Then Table 17 shows feeding that same script back to explain it.
Yep, great for understanding unfamiliar code.
And Table 18 translates the bash script to Python.
Again, very handy. But test the translated code too. And the source mentions clicking Markdown in Vertex AI Studio for proper code formatting, which is a good practical tip.
Then debugging. Snippet 3 has broken Python code. Snippet 4, the error message. Table 19 feeds both to Gemini.
And the output nails it, identifies the name error, suggests using .upper, provides corrected code, and suggests further improvements like error handling and f-strings.
That's impressive, though it notes the response was truncated token limits again.
Always something to watch.
And a quick note on multimodal prompting.
Just clarifies that while code prompting uses the text LLM, true multimodal involves models that handle images, audio, etc. alongside text.
Okay, massive range of techniques. Now the best practices section seems like a distillation of key advice. Providing examples, one shot, few shot, comes up again.
Top of the list, pretty much. It's just so effective for teaching the model exactly what you want. Structure, style, tone, everything.
Design with simplicity. Keep prompts clear, concise. Avoid jargon. The rewrite example for the New York travel query makes that clear.
Yeah, simpler is usually better. Easier for you to write, easier for the model to understand, less chance of misinterpretation. Using those action verbs helps too.
Be specific about the output. Generic instructions aren't enough. The video game console blog post examples show the difference.
Absolutely. If you want specific points covered, or a certain length, or a particular format, you have to ask for it specifically. Don't make the model guess.
And use instructions over constraints. Tell it what to do more than what not to do.
Generally, yeah. Positive instructions are often clearer. Write a summary focusing on X is usually better than write a summary but don't include Y, Z, or A. Constraints are still needed, especially for safety or strict formats, but lead with instructions.
Okay. Other quick hits. Control max tokens.
Either in configuration or ask in the prompt like explain in tweet length.
Use variables and prompts for reusability. Table 20 shows city.
Super useful for plugging prompts into apps.
Experiment with formats, styles, wording. Different ways of asking for the same thing can yield different results.
Definitely. Try phrasing as a question, an instruction, a statement. See what clicks with the model.
For few-shot classification, mix up the class order in examples.
Smart tip. Prevents the model just learning the order instead of the actual classification logic.
Adapt to model updates.
Models change. Keep up, adjust prompts. Tools like Vertex AI Studio help manage versions.
Experiment with structured outputs like JSON, especially for non-creative tasks.
Big benefits. Consistency, less hallucination, easier processing. Table 4 again.
But watch out for truncated JSON. Use repair tools if needed.
Yeah, like the JSON repair library mentioned. Good practical advice.
And use schemas for input, too, to structure the data you give the LLM.
That's a powerful idea. Defining the input structure helps the LLM understand relationships, data types, focus on the right info. The product data schema example illustrates this well.
Collaborate. Get multiple people trying prompts.
Fresh eyes often spot improvements.
Specific coded tips. Answer after reasoning. Make the answer easy to extract. Use temp 0.
Good refinements for using code effectively.
And the big one, document everything. The Google Sheet template was really helpful.
Cannot stress this enough. Goal, model, settings, prompt text, output, iteration, whether it worked, feedback, track it all. Link to saved prompts if using a tool like Vertex AI. For RAG, track RAG parameters too. Keep prompts separate from code. Use automated testing for operational prompts.
Phew, that's a lot of best practices. It really underscores that prompt engineering is iterative. Craft, test, analyze, document, refine.
And keep experimenting, especially when models change. It's a continuous learning process.
Okay, what a journey through prompt engineering. We've hit LLM output configuration, tons of techniques from zero-shot all the way to React and code prompting.
And wrapped up with those crucial best practices.
It really highlights how just, tossing a vague prompt out there often isn't enough. These techniques are key.
Absolutely. Understanding and applying them unlocks so much more potential from these models.
So for everyone listening, the challenge is yours now. Take these ideas, start playing around with your own sources, your own tasks.
Yeah, try out different techniques. Could few-shot help? Would a system prompt enforce the format you need?
Maybe think about structured data. Could using JSON for input or output make your interaction smoother, more reliable?
How can these techniques specifically address your needs? Keep exploring, keep testing.
Definitely. Thanks for joining us on this deep dive.